Lesson 2, Properties of Operation. Our objectives in this lesson is to identify the properties of operations and to illustrate the properties of operations. This is your list of vocabulary words. You need to know what these mean. I have included a list of the definitions in your coursework. Please learn these and memorize them. Use some flashcards, make whatever you need to learn these. It's important because you're asked a lot of questions, whether a certain problem is commutative or associative, or what type of operation is being used. So it's important that you know these. Please don't just ignore them. Adding and subtractions are inverse operations. We can undo an addition problem by subtracting one of the add-ins from the sum. So here you've got the 2 plus 3 is 5. Well, if you take the 5 minus the 3, it's a 2, or 5 minus 2 is a 3. And we see this down here that we can do that. Those are inverse operations. We see that both the 2 plus a 3 and 3 plus 2 equal 5. Changing the order does not matter. The characteristics of addition, this characteristic of addition is known as commutative property, meaning that we can take these and we can scramble them up and it's not going to change anything. We're still going to get the same answer, whether it be 2 plus 3 equals 5, or 3 plus 2 equals 5, or 5 minus 3, or 3 minus 5. Those are both going to come up with the same answers. That's commutative property of addition. And we can do that. We can scramble them up like a community. Think of a community and everyone in it. And it doesn't matter if you move them from house to house, they're still part of the community. And if there's population 10, even if you move them around the houses, there's still 10 people. It's the same idea. So I like to think of commutative as community and commutative property of addition. The identity property of addition states that when 0 is added to a given number, the sum is equal to that given number. So a, being the variable, plus 0 equals a. And we can substitute a lot of things for that a. So the 0 is the additive identity. Multiplication and division are also inverse operations. Dividing the product by one of its factors undoes the multiplication. Here we see that 4 times 5 equals 20. Well, 20 divided by 5 is 4, or 20 divided by 4 is 5. Together, the numbers 4, 5, and 20 form a multiplication division fact family that can be arranged into 2 multiplication facts and 2 division facts. Here you've got 5 times 4 is 20, and 4 times 5 is 20. And likewise, 20 divided by 5 equals 4, and 20 divided by 4 equals 5. Again, this property is commutative property of multiplication because we can scramble them up. We can scramble them up, but yet they still come out equaling 20. So when you look at that written with variables, it's a times b equals b times a. It doesn't make a difference. You still come up with the same answer. That's the commutative property of multiplication. And remember, identity property of addition is that anything added to 0 is that particular thing. So 8 plus 0 equals 8. Since changing the order of division may change the quotient, division is not commutative like addition and multiplication is. Multiplication is commutative. 4 times 5 does equal 5 times 4. But you'll notice that in division, that 20 divided by 5 does not equal 5 divided by 20. Not even close to being the same thing. So the identity property of multiplication states that when a given number is multiplied by 1, the results equal the given number. Thus, 1 is the multiplicative identity. So just like our identity property of 0, in this case here it's in multiplication, a times 1 equals a. So 10 times 1 equals 10. 1,000 times 1 equals 1,000. 1,000,000 times 1 equals 1 equals 1,000,000. So anything we multiply by 1 equals that number. That is called the identity property of multiplication. And anything we add to 0 is the identity property of 0. The property of 0 for multiplication states that when a number is multiplied by 0, the product is 0. So if they said, what property does that illustrate? You would say the property of 0 for multiplication. If they ask you on a test, what property does this illustrate? You would say that illustrates the identity property of multiplication. If you saw this and they said, what property does that illustrate? You'd say that illustrates the commutative property of multiplication. understand that division cannot be commutative because these do not equal the same thing. The operation of the arithmetic are binary, which means that we only work with two numbers in one step. If we wish to add 2 plus 3 plus 4, we can add two of the numbers and then add the other number. Parentheses around the 2 and the 3 in the expression below shows that 2 plus 3 should be treated as a single quantity. Therefore, 2 and 3 should be added, and then 4 be added to that sum. So you can see that here, you're just going to add that together, which gives us the 5, then add that to the 4, which gives us the 9. You don't go 2 plus 3 plus 4, you go 2 plus 3 is 5, plus 4 is 9. In the expression below, the parentheses indicate that the 3 and 4 should be added first. So instead of doing the up here, instead of doing the 2 and 3 first down here, we're going to do the 3 plus the 4 first, which is 7. Add the 2 to that, it still equals 9. So it doesn't matter whether we do this part first or this part first, and we're still going to get the same answer. Notice that the sum in the same, that they become the same no matter which ones we do first. This is called the associative property of addition, which just says that we can hang out with different friends and it still ends up with the same answer. We're not scrambling them up like we did in commutative property. We're just, the parentheses is what's changing, which ones we're going to do first. And when you're allowed to do that, that's the associative property of addition. The associative property of addition states that the grouping of add-ins does not change the sum. There's a similar property for multiplication called the associative property of multiplication, where the factors do not change the product. So if you look at your properties of operations, here's our commutative properties. You notice here that the order of the variables is being scrambled up. Down here they do not get scrambled, but we work on different ones first. In this one here we do the AB before we add the C, and over here we do the BC before we add the A. And this works for both addition and multiplication, as does the commutative properties. Then you need to remember the identity properties of A plus 0 equals A, and A times 1 equals A. And in the property 0 for multiplication, A times 0 always equals 0. This table right here is something that I would write down in your math book, your math binder somewhere to keep handy, to refer to. It's a great reference. So let's go ahead and try this. Name each one of these properties illustrated. Pause the video, see if you can answer all of these, and then let's see how you did. So in A, this 5 times 3 is 3 times 5. We're scrambling them up, but it doesn't change our answer. So that is the commutative property of multiplication. The second one down in B, we're not scrambling the numbers. We're just changing what operations we do first. Here we're adding the 3 and the 4 first. Here we're adding the 4 and the 5 first. So we're associating them differently. We're not scrambling them up. That's the associative property of addition. In C, we have 6 plus 0 equals 6. That's the identity property of addition. And 6 times 0 equals 0 is the property of 0 for multiplication. If you didn't get that right, rewind it, try it again. In example 2, which property can you use to find each unknown number? In this case here, 8 plus what would equal 8? Well, 8 plus 0 would equal the 8. So we know that that property is going to be the identity property of addition. Here, 1 times what would create a 9? Well, anything times 1 is itself, so it's the same thing as the identity property of multiplication, which says that anything times 1 is itself. And then down here, we see that what would have to be there in order for this answer to be 0. So 10 times 0 equals 0. Anything times 0 is 0. That is the property of 0 for multiplication. Example 3. Dina simplified 4 times 15 times 25 in 4 steps. You're going to justify each of these steps. So you're going to look right here. Here's the given expression. This expression just means the problem, right? So 4 times 15 times 25. Then down here, what has happened here? What has she done here? Did she associate them different? Did she scramble them? What did she do? Write down what you think that property would be, what she did in that situation. Then go down here and say, what did she do there? And then what did she do there? And how did she get this? These are a little bit tricky, so let's go ahead and review this one. So we study how Dina changed expressions from one step to the next. To the right of each step, we justified that step by stating the property or operation that Dina used. So in this very top one, we have the expression. Next thing we do is right here is commutative. This step right here is the commutative because she scrambled them up. In this one here, she didn't scramble them up. See, she went from this association and associated the 4 with the 25 first instead. So that is the associative property. At that point, all she did was multiply 4 and 25 to get 100, and then she multiplied 115 to get 1500. So this you'd write right there on your test. Here, you'd write that on your problem. This is what you'd write here, and this is what you'd write here. Sometimes these are very confusing. They're hard to see, but we'll do enough of them that you'll get very familiar with them. These are your tickets in the door that you need to do. I want you to go into the submit file, type in these numbers and your answers that you come up with. So I'll have them before tomorrow morning, and we'll see you in class.